We're going to talk about a story today that connects these massive glowing machines from the past to the AI that's probably in your pocket right now. It's this incredible tale of innovation, a really strange mystery, and a computer that was, of all things, afraid of the dark. Okay, so on one side, you've got the world we know, sleek, powerful AI. And on the other, you have its ancestor, a room-sized maze of wires and tubes from 1948 called the OMIBAC. I mean, it seriously looks like something from another planet, right? But believe it or not, the DNA of our modern world is hidden right inside that beast of a machine.
So, that's the big question here. How in the world did we get from a machine with this bizarre fear of the dark all the way to the sophisticated AI we have today? Well, to figure that out, we have to go back and meet the machine itself.
And when I say meet the machine, I really mean it. This wasn't just some abstract idea on a whiteboard. This thing was a physical, one-ton beast of pure engineering. And here it is. We're in 1948, right after World War II, and a team at General Electric pulls the curtain back on the OMIBAC, which stands for the Ordinal Memory Inspecting Binary Automatic Computer. It was a genuine trailblazer for its time.
Probably the best way to wrap your head around what this thing did is to think of it as a calculator on steroids. Its whole job was to chew through these incredibly complex math problems for the US Air Force. We're talking things like missile trajectories, calculations that were just impossible for humans to do quickly.
And to get that massive job done, it needed 3,300 of these thermionic vacuum tubes. Just picture thousands of old-school light bulbs, all glowing hot, acting as tiny little switches to process information. The sheer scale of it was mind-boggling for the time. And all those tubes? Well, they were incredibly thirsty for power. The OMIBAC sucked down 12 kilowatts of electricity. To put that in perspective, that's enough juice to light up an entire small neighborhood. It also got so hot that they had to constantly blast it with cooled air just to keep it from literally melting down. Now here's a great little detail, where its name came from. I mean, officially, it's an acronym, but unofficially, it was a backronym, cooked up by an arthritic worker who had to haul the machine's one-ton framework during construction. He started calling it the OMIBAC computer, and the name just stuck. You gotta love that. And get this, just to add to the sheer physicality of this thing, its power supply had a backup. And that backup was a bank of enormous, incredibly heavy submarine batteries. This wasn't about elegant software. It was a challenge of brute force engineering. But, beyond its crazy size and power consumption, the OMIBAC had a secret weapon, a truly revolutionary feature that set it apart, and really planted the seeds for everything that came next. And that weapon was something called hardware floating point arithmetic. See, before this, computers could pretty much only deal with whole numbers. But the OMIBAC, it was built from the ground up to handle messy real-world numbers, the ones with decimal points. And that one feature, that alone, made complex scientific calculations possible for the very first time. There's a brilliant way to think about this. Imagine you're trying to measure something. Older computers used rigid rulers. They were great for exact whole numbers. Floating point was kind of like using stretchy rubber bands instead. It gave the machine this incredible flexibility to represent a huge range of numbers, from the tiniest fractions to absolutely enormous values. And this kind of gives you a sense of just how complex that innovation was. It wasn't some simple fix. It was a total rethinking of how a machine could even understand numbers. This flexibility was the key. It unlocked the door to the kind of complex simulations that today are the bedrock of AI training. But this trailblazing machine, it had a problem, a really weird one. The engineers, led by the chief architect George Hobbs, were just completely stumped by this mystery that only happened at night. Every single night, without fail, if the machine was left to run by itself in the dark, it would crash. But if an operator was in the room with the lights on, it worked perfectly. You can imagine they were just pulling their hair out trying to figure out what was going on. It led them to this strange, almost unbelievable conclusion. As the engineers kind of joked, the OMIBAC was, for all intents and purposes, afraid of the dark. But they were engineers, right? They knew there had to be a real scientific reason. And this was the culprit. These are the machine's memory circuits, called Jordan-Eccles flip-flops. And they used these tiny little neon bulbs to show whether they were storing a 1 or a 0. And it turned out these little guys were sensitive to light.
So here's the science behind it. The amount of voltage needed to light up those little neon bulbs, that's their ionization potential. It actually changed depending on how much light was in the room. In total darkness, that potential shifted just enough to cause random glitches and bring the whole system crashing down. So, the solution? Oh, it was absolutely ingenious. The engineers took a tiny dab of radioactive radium and applied it to each and every bulb. This made them glow ever so slightly on their own, which kept that ionization level perfectly stable, whether the lights were on or off. Problem solved. So this whole story is way more than just a quirky anecdote from computer history. Solving that problem and building that incredible machine in the first place was a crucial step on the path to the world that we live in right now. You can literally draw a straight line. It starts in the 40s with OMIBAC introducing hardware floating point. That innovation makes more complex machines possible in the 50s, when transistors take over for tubes and the term AI is first coined. And that leads to integrated circuits, which leads to personal computers, and eventually to the massive data processing and deep learning of the 2000s. All of it powered by the evolution of that original floating point concept. Seriously, without OMIBAC's breakthrough, this whole timeline looks completely different. So, what's the real takeaway from the story of a one-ton computer that was scared of the dark? Well, it's not just about the technology. It's really about the people. It's about the human element. The engineers working on OMIBAC had no idea they were laying the groundwork for self-driving cars or AI that could write a symphony. They were just driven by curiosity and the sheer grit to solve whatever bizarre problem was right in front of them, even if that meant dabbing radioactive material on thousands of tiny light bulbs in the middle of the night. And that kind of leaves us with a final thought, doesn't it? The work they did back in 1948 blossomed into the world we have today. It really makes you wonder, what seemingly small, quirky problems are we solving right now? And what seeds are we planting that will grow into the unimaginable world of the future?